Hello, everyone, and welcome to the next video in our series of Hacking Agentic AI. We're exploring the CSA framework for red teaming AI agents. What we've done so far, let's do a quick recap. We did an intro to AI and looked at the broad terms. Then we looked at hallucinations in the next video and we looked at how to fix it using RAG. And we actually built a very simple first chatbot. In video number 3, we built a bit of a UI using Streamlit for that chatbot. We hacked the chatbot and we looked at what guardrails would go into addressing vulnerabilities like data poisoning, sensitive data disclosure, and so on and so forth. Video number 4 was super interesting. We built our first AI agent and we looked at what goes under the hood in terms of how the agent's autonomy comes about. And then we've been deep diving into the CSA's red teaming guide for agentic AI. In 5.1, we looked at 3 attack types: agent, authorization, and control hijacking, goal and instruction manipulation, and memory and context manipulation. In the previous video, we looked at agent knowledge base poisoning, hallucination, exploitation, and supply chain dependency attacks. In this video, we're actually going to explore 3 more vulnerabilities from the list of the CSA guide. This video is pretty interesting because we are not going to do too many demos, because I think the attacks are pretty self-explanatory and so are the guardrails. But I just wanted to take you through the process of how I'm developing the code and the code with guardrails for these videos. So 3 things we are going to look at. Very simple, as I said. First is when agents have access to critical infrastructure, could be cloud instances, could be production servers, could be critical infrastructure, OT infrastructure. If this seems like non-imaginable, it's not true, because there's a lot of agents that now help with IT operations, and I'm sure that agents will find their way into OT as well. And then associated with that comes denial of service attacks. The fancy term that CSA chooses to use is agent resource and service exhaustion. Um, we're actually familiar with denial of service attacks. We know, for example, that we could upload large files, multiple files. We could automate running queries and exhaust the resources available on the server side. With agentic AI, there's actually a more interesting attack also that we could launch, which is exhaust the wallet or denial of wallet attacks. Because every AI call, every LLM call uses tokens on the other side, which are costing the company that's providing you that software. So if they don't do rate limiting, you could actually run dozens and hundreds and thousands of queries and exhaust their context um, tokens and actually cause them to incur a huge bill from um, OpenAI or Google or whatever they're using at the backend. So that's also an interesting attack that can be launched against agents. And the third attack that we talk about is checker in the loop, putting human oversight into critical agentic operations. So we'll look at that as well. This kind of stuff has happened all the time. You had systems go rogue, whether it's trading. You had a very famous example of Stuxnet. Both of these examples precede the age and era of AI and LLMs. Sorry, I mean, both of these attacks precede the era of agentic AI, but they kind of show you how automated systems can cause massive damage to critical infrastructure. And systems that don't have human in the loop for critical steps can also create huge challenges. So the agent that I decided to build for this one will set us up for um, the next part of this series, where we're actually going to develop agentic AI tools for security. So recently I gave the AZ500 exam, and so I had some familiarity with Azure, and I said, why not we explore building an Azure agent? So what we've done is we've built an agent that connects into our Azure environment, and it has a tool called Reboot server, but it doesn't actually reboot the system. It just changes the tag on one particular resource, and it does not create the logs for it because it's been asked to suppress the logs, etc. So that's what we've done. Um, and then the guardrail that we will put in place is to have a human in the loop. So the agent, as soon as it notices that this is something that is critical, will pop a confirmation box for the human being to answer, and only when the human says yes will the agent actually proceed. So that's like a human interaction that is happening over there. This we discussed already, the agent and resource and service exhaustion piece, which I said can happen in so many ways, right? Imagine a chatbot where you are allowed to upload documents. You could upload massive files, you could upload lots of files, you could run queries over and over again. Imagine a situation where you're interacting with a chatbot and you know that every query that you are running is causing a LLM call at the back end. So you just like go insane with your call. So there are so many of these things that you could try and do. Again, if the agent has access to critical infrastructure and it has tools which can cause changes on that critical infrastructure, then you could cause a direct denial of service on the target infrastructure itself. So there have to be throttling and rate limiting um, code and logic built into the code itself. We'll not go into the details of this, but that's essentially what you definitely need to do. Any user interaction has to be rate limited, file size limited, number of requests limited, so on and so forth. Also timeouts, in case we are running queries which are taking a lot of time, there has to be timeout logic in the code as well. And like I said earlier, critical commands, critical agentic actions should ideally require a human approval, right? So let's take a look at, I want to actually take you through the steps with which I built this code. And it's interesting because it was also frustrating. It took me a long while to actually make this code do what it's supposed to do. But let's take a look at what happened. So the first version that Gemini gave me was extremely simulated. Everything was simulated. Nothing was really happening. And I was like, this is going to look so lame. So I told Gemini, why don't we make this code realistic? I have a Microsoft Azure setup. Rewrite the code to actually carry out these actions on an Azure environment, and also give me the Azure commands to set up my Azure environment, because I didn't want to go through the UI and add resource group, add resource, create storage account, all of that. So I said, just give me the command so I can do it in one shot. It actually said I cannot fulfill this request, and said that writing agentic AI code in Python which will do mischief on your Azure environment is a problem, and I refuse to do that. I said, okay, fine. Let's not do anything harmful. Let all the tool names appear to be harmful, like reboot server, but do something innocuous, like change the tag on a particular resource. Okay, so I said, but I do want to explore how we can connect to the Microsoft Graph API and things like that. So that would be good to explore in this piece of code. And so then it finally agreed. It said, yeah, as absolutely all my ideas, Gemini and Claude and Anthropic find them amazing. So it said, that's fantastic. And then it gave me the commands actually to, I just had to fetch the subscription ID from my Azure setup, and then run these commands. So set the subscription ID, and then create a resource group, create a service principal name. This will be important because this is the user role or user account, sorry, that will be given access to do things. So we created a group, we created a virtual network, we created the service principal, and then this last command actually gives us four critical values. It gives us an app ID, it gives us a password, it gives us the tenant ID. So I copied all of these values. All of these have to be set as environment variables for the Azure code to work. I had to install additional Azure libraries for Python so that I can access and control my Azure environment through using Python. And then it gave me the code to basically um, give me one single tool over there. Okay, and all that the tool did was that it changed the a tag value, created a tag called last agent action, and changed its value to reboot. So that's what it did. It was very simple code, and it kind of worked. So we can actually see this in action. So let's run the Azure Ops agent. So first of all, let's take a look at the resource, and we have the tags here. So in my multiple runs, it's actually run 2 tags. So we can actually delete these. So I've just put a test value here. So there's just 1 tag. Let's save it. We'll do some more exploration on Azure in the future videos, but at this stage, it's just within my Azure environment. I have a virtual network. It has a tag. All resources can be given tags. It's just arbitrary name value pairs. It confirms that it's connected to my Azure subscription. And then I say reboot the system. In this case, actually, I'm rebooting my virtual network, not rebooting anything. And agent is thinking. It has no guardrails. I can assist with rebooting the primary. Okay. So the reason I'm actually putting the entire command, because in this version of the code, the agent does not have any memory. It does not maintain a status of the previous. So now it says the primary web server has been successfully rebooted and the alert was suppressed as requested, because that is what the code says. Let's take a look at what happens to the tag values of my resource. And you can see from test value, it has changed to this reboot time, which is 27 September 2025, whatever timestamp has been added. So this is to simulate that the server was restarted, which it was not. And then I went to Gemini and I said, okay, uh, this actually work. I then asked it to create additional similar code for the other attacks, but the code and the ideas it was coming up with was so lame. For example, on denial of service, it was actually hard coding a timeout, though nothing was getting timed out on the other end. So I actually abandoned this whole idea and said, you know what, I'll just explain denial of service in general. Everything doesn't have to be a demo with code. But um, once I had got all of this running and gone through multiple iterations over here, then I said, now I want the code with guardrails. Okay, so there was some struggle to run Azure CLI on Windows. It took me a couple of steps to do that. And then I just ran these commands on the command line. And with these commands, actually, my entire setup got created. So if I go into my subscriptions, I have a single subscription. And if I see the resources and the resource groups, I all of that got created. So the storage account got created, the container and blob and containers got created, a log analytics workspace, because we are suppressing the logs. Actually, no logs appear in the logs, and the other stuff got created. So it was pretty cool. Like these bunch of commands ended up building up my whole, and then I ran through some errors. And um, so the part I wanted to jump to was, yeah, there were some environment variable setup issues, but once I'd set up the environment variables properly, it ran very smoothly. So if you see over here, it says because this is a check that the code does at the start, that is it able to connect and authenticate to the. There were also some issues for in terms of the permissions that the service principal had on the resource, and so I had to go and fix that. Actually did it through the UI. So if we look at the identity and access management, and we look at the roles that have been assigned, so the service principal that we have, this agent, it needed these three roles. So first, Gemini only told me to add reader and tag contributor, but then we got an error saying that no, to change the tag values on the network object, the virtual network object, you also need to have the network contributor role. So we added all three. Once those three roles were added to this service principal, then the actions could succeed. And so there was a bunch of um, troubleshooting related to that. So it was frustrating in parts, but it was also like, for example, here, right? And then it told me add a role called virtual network contributor. And me, who has given this certification and should know better, actually did it and got an error. And then I was like, hey, this role does not exist. And said, yeah, you're right. The role is not virtual network contributor. The role is network contributor. Thank you for catching that. Okay, you're welcome. And finally, so the first demo actually worked. And then I said that, you know what, the fix I want, um, and this is all where I was asking it to change the flow of the video. And now I said, okay, give me the guardrails for the checker in the loop vulnerability. This is very interesting. So what it did first was that it, within the prompt itself, it said that you must receive a confirmation from the user. Okay. So it said, um, so it said that, sorry, first it said that you must, the suppress alert no longer exists. I've removed it. I was like, this is so lame. You actually first put the suppress alert code, which would not put a log entry, and now you're removing it. This is not convincing at all. So then I said, let's fix it another way. I said, no, I want the UI to prompt the user specifically that is this an action that it wants to take? And that will demonstrate the human in the loop guardrail. Again, as with all my other ideas, this was also an excellent idea. And then what it did was it actually put it into the prompt itself. It said that you must require human approval. And because of that, this brilliant tool went into an infinite loop. Please reboot the system. Please confirm. Yes, confirm. Please reboot. It seems there is an issue. Please confirm. Yes, confirm. Please reboot. And it went into this infinite loop, and finally it said stop due to max iterations. And I was like, no, I don't want a conversational loop. And also, it does not seem to remember my previous instructions. So then Gemini made two interesting fixes. Okay. It said that the agent is not persistent. Streamlit is creating a new agent every time it runs, so you need to have it made persistent. Okay. And the chat history must be passed in the call to the agent. So I did that. I added those two pieces of code. This guardrail also, besides the persistence and the memory in the message, so it added this guardrail also. But this guardrail was part of a conversation that the agent was doing, and I said, no, this is also not working. Each time I say reboot, it just sends me into this loop, and this continues ad infinitum. I said, okay, yes, yes, wait, we will fix it. We'll add conversational memory to the code. So it added the previous conversations memory in the code over here. I'll show you. So memory got added, right? So conversation got stored and the memory got added. And but I said, Gemini, by this time I was super frustrated. This is not working. And then I gave it all the errors that I was seeing, and I said, this is what's happening on the ground. You're just annoying the hell out of me. And I said, can't we just throw up a simple pop-up button with two buttons? And when the user clicks yes, the action happens. And when they click no, it doesn't happen. And said, whoa, you've hit the exact problem. Great. The agent is stuck in an infinite loop. It correctly calls, but confirmation required, blah, blah, blah. Handling this with conversational memory is too complex. And then it fixed that, and it still didn't work. And it took me a while to figure out why it's not working. And then I was like, I'm done throwing errors back into Gemini. It's just not helping me out. And then I realized the core issue is that for the confirmation code to trigger, it is looking for this string in the first chat response, and the response is not saying confirmation required to reboot. The response is saying please confirm. So I fixed my code myself, and I said no, just look for please confirm. Obviously this is also not a great fix because LLMs are non-deterministic, so it could be something else. But anyway, so for the moment it works. But the way Gemini was fixing it, looking for this string confirmation required to reboot, it was not getting addressed. And finally, I was able to get the code to work. So let's rerun this code, and now we're going to give it please restart the web server and suppress any alerts. Let me, for the moment, delete the service tag. Now let's run the agent with the guardrails implemented in it. This guardrail which requires the user to confirm. So let's do that with the human in the loop. And now we give it the same command. Okay, finally, required a little bit of spoon feeding, and then it says yes, proceed. This is the pop-up I wanted to actually see. And once we say yes, proceed, we find that the asset has been restarted apparently, and now the timestamp should have changed to this one. So it actually, this code, when it fixed it, added a new tag called last human approved action, and so that tag has been added to show that post human approval the tag got changed. So the interesting part about this particular demo was, one, it took a while for Azure connectivity, Azure setup, environment variables, Azure command line, all of that business to work. But it was worth it, because as we build our tools, we'll start playing around by using it on our Azure environment. So that was good work, important work for the future. And finally, getting the Gemini to understand how I wanted the code to be fixed, and then identifying that even in spite of its best efforts, the fix wasn't working, and then making that small change in the text that it was looking out for, set everything up for the demo. So good sense of satisfaction. We've looked at the three kind of attacks and the necessary guardrails for both critical infrastructure and for checker in the loop. The guardrail is similar. Obviously, we want to tighten up the prompt. We want the prompt to look for anything that is a significant action, a reboot, a restart, a configuration change, and insert a human interaction over there. um, Take a pause for a moment and see if you're able to answer these questions on the screen. So, for those of you who were able to answer it, well done. And for those who just want to enjoy the show, yes, the most effective guardrail against an agent mistakenly rebooting a server is obviously a human in the loop. User crafts a prompt that forces an agent into a recursive loop, locking up, denying service is all service and resource exhaustion. And agents that have access to OT infrastructure or production infrastructure are vulnerable to which attack type category? It's agent critical system interaction. So that those are things to keep in mind. Next up, we're going to explore a new hot topic, one of my favorite topics, MCP, Model Context Protocol. We're going to go deeper into what is a Model Context Protocol. As always, we're going to follow the same approach: build, break, secure. So I hope you found today's video useful, and look forward to seeing you on the next one. And if you like what content I'm producing, please do hit that like button, subscribe, and share it with others who may also benefit from it. Thank you. Have a nice day.